Welcome to Ask and Learn.
We have two weights, each weighing 100 newtons, attached to a spring scale, as shown in the figure here. So these weights, gravity is pulling down on them, they're pulling on the spring scale, and we want to know if the spring scale measures 0, 100, or 200 newtons, or possibly something else. If we isolate the spring scale and each mass from each other, this mass has its weight 100 newtons, a force from the spring scale. Likewise, this block has a weight of 100 newtons and the force from the spring scale. The rope transfers this force around from the block to the spring scale in both cases, and then this force acts on the spring scale. Now, these two forces are equal because of Newton's third law. Same with these two. These two are equal, and these two are equal because of Newton's third law. And because the rope attaching the block to the scale is assumed to have no mass, then this force must equal this force. So they're all just F. So if we look at what force is acting through the spring scale, you see that the scale should read 100 newtons. Now, let's just look at the case in which one side of the spring scale is attached to a wall. Okay, so now we have, instead of another mass over here, we have a rigid wall. If we draw the force diagrams, you see we have a force from the block, or the weight of the block, force from the rope carried around to the spring. Then instead of another block over here, we have the force from the wall acting on the spring and the force from the spring acting on the wall. And again, F in all of these cases is going to be 100 newtons if this block is in equilibrium. So we should get that the scale reads 100 newtons again.